In this video, I will describe how to start the Magnum outside of the car in two ways, with fuel injection and with a carburetor. The 5.9 Magnum engine in the Jeep Grand Cherokee ZJ and in some Dodge vehicles with this engine, meaning the second generation Ram, first generation Durango and second generation Dakota, are equipped with an immobilizer. However, the 5.2 Magnum engine in the pre-facelift Jeep Grand Cherokee ZJ does not have an immobilizer. Therefore, the best and simplest way for a garage startup is to buy an ECU for this engine that does not have an immobilizer. Based on my research, these are the ECU units with the number 56040. I happen to have ECU number 56028, and in those cases the absence of an immobilizer is a matter of chance, as some of them had an immobilizer while others did not. My 56028 unit happens to not have one. We begin every action of this type by analyzing the engine wiring diagram. I will do my best to describe every plug that is shown on this diagram. Let us start with the ECU. The ECU has three sockets. On the diagram they are marked as C1, C2 and C3. However, on the ECU itself the markings are different, A, B and C respectively. Each pin in every socket has its own number, but only the outer pins are labelled. And so, on this photo, from the top and from the left from 1 to 11, below from 12 to 21, and at the very bottom from 22 to 32. In the center you can see the marking A and in the adjacent socket B. To finish up with the immobilizer topic, I will just add that in a factory vehicle, a grey ignition key means it has a built-in immobilizer chip and of course a functioning immobilizer system. On the other hand, a black ignition key indicates the absence of an immobilizer. Main power supply. Pin C122, constant 12 volt power from the battery through a 20 amp fuse. Pin C12, switch 12 volt power from the ignition switch through a 10 amp fuse. Pins C131 and C132, main thick grounds for the computer. They must be solidly bolted to the engine block or the negative battery terminal. Additionally, we have a constant 12 volt power from the battery to feed the automatic shutdown relay through a 20 amp fuse. And the switched power from the ignition switch also supplies the oxygen sensors through a 10 amp fuse. Let us now go through the remaining ECU pins one by one. D319 fuel pump relay activates the fuel pump. D320 EVAP canister purge solenoid. This valve opens the connection between the fuel tank and the intake manifold at medium engine speeds to burn the vapors. We ignore this. C311 stop light switch, used only to deactivate cruise control in the automatic transmission setup. When the brake is not pressed, a constant 12 volt power is present on this pin. The moment the brake is pressed, the circuit opens and the voltage drops to 0 volts. That is when the cruise control gets deactivated. We ignore this. C310 and C314, leak detection pump switch and solenoid. This is an environmental emissions pump for gas tank leak diagnostics. It works like this. Alternating vacuum from the intake system controlled by the ECU drives the pump. Once the proper pressure value is reached, the pump turns off and the ECU measures the pressure drop time. A time that is too short indicates a leak. We ignore this. D33 ground output that triggers the automatic shutdown relay, which is the main relay for the injectors. D312, the ECU measures the presence of 12 volt power here. D17, ground pulse that triggers the spark on the ignition coil. C225, output generator field control, which is the alternator driver. C24, C215, C25, C216, C26, C212, C22 and C213. Injectors. C18 crankshaft position sensor pin 1. C114 camshaft position sensor pin 2. This is a clean sensor ground generated by the computer, completely isolated from electrical interference. You must connect this exclusively to the engine sensors, never to the car body or the engine block. C326 fuel level gauge or float. The computer sends a constant current to the fuel tank sending unit float. Depending on the fuel level, the resistance on the float slider changes. Empty means high resistance, full means low resistance. The ECU converts this into voltage and sends the data code via the CCD bus digital network to the instrument cluster. We ignore this. C118 camshaft position sensor pin 3. This is the signal input from the distributor, or the camshaft signal. It is used for fuel injection phase synchronization, known as fuel sync. D117 5-volt sensor power supply. C123 throttle position sensor TPS signal. D127 manifold absolute pressure sensor MAP signal. C332 sensor ground for the vehicle speed sensor VSS in the 2-pin version. We ignore this. C14 a clean sensor ground generated by the computer, completely isolated from electrical interference. You must connect this exclusively to the engine sensors, never to the car body or the engine block. C322 AC low temperature switch or freeze switch. When it gets too cold, this sensor opens the circuit. Then the ECU disconnects the AC compressor relay, even though the AC button inside the cabin is still pressed, allowing the evaporator to defrost for a moment. Once the temperature rises, the computer engages the compressor again. We ignore this. C323 input AC select request, which is the air conditioning switch. 12-volt power appears here. It informs the ECU about the driver's intention. This gives the ECU time to prepare the engine for a sudden load by bumping up the idle speed. We ignore this. D223 oil pressure sensor. D324 control anti-lock brake. When the brake is not pressed, there is 0 volts on this pin. Only after pressing the pedal, the circuit closes and 12-volt power appears here. This is the exact same line that physically lights up the stop bulbs at the back of the vehicle. Pin C324, along with the previously described pin C311, serves exclusively for braking control for the cruise control and the automatic transmission to unlock the torque converter lockup. Furthermore, if one circuit fails, the ECU will see 12-volt power on both pins simultaneously or 0 volts on both pins simultaneously, immediately knowing that the sensor above the pedal has failed. We ignore this. D327 transmission from the ECU control anti-lock brake and the OBD2 data link connector pin 6. C115 intake air temperature sensor. C116 engine coolant temperature sensor. C36 output AC clutch relay. When the engine properly increases its revolutions because the air conditioning was turned on via pin, C323 pin 36 receives a ground signal and connects the ground to the AC compressor relay coil, which activates the clutch on the AC pump. We ignore this. C119, C110, C111 and C120 idle air control motor. C327 pin 6 of the OBD2. C329 pin 11 of the OBD2. C330 pin 3 of the OBD2. C328 pin 7 of the OBD2. C34 and C35 cruise control vacuum valve control. We ignore this. C16 if the ECU is from a manual transmission setup, we connect to ground here. If the ECU is from an automatic transmission setup for valve power supply, we ignore this. C211 park neutral position switch for the automatic transmission. We connect this permanently to ground. For a manual transmission setup, we ignore this. C229, C28, C221, C230, C231 and C21, we ignore this. C225 and C228, output shaft speed sensor plus and minus. This is the output shaft speed sensor in the automatic transmission. We ignore this. C313, overdrive off switch, which is the overdrive deactivation button on the automatic shifter. We ignore this. C124, downstream O2 sensor signal, which is the sensor after the catalytic converter. C125, upstream O2 sensor signal, which is the sensor before the catalytic converter. C231, a clean sensor ground generated by the computer, completely isolated from electrical interference. You must connect this exclusively to the engine sensors, never to the car body or the engine block. In the end, I built the wiring harness myself, basing it on the cables from a Jeep Grand Cherokee ZJ. Among other components, I utilized the fuse box and all the necessary connectors. And here are a few photos of that work. Summary of the Magnum fuel injection system wiring. You need an ECU without an immobilizer, which means one with the number 56040. You connect all the sensors according to the diagram, while you ignore the following pins. Finally, you can also connect the instrument cluster. Alright, time for the guide on mounting a carburetor on the Magnum engine. In a way, it is a blast from the past, because the previous version of the Magnum engine, the LA which stands for light automobile, had a carburetor. We start with the top street performance JM6713BL distributor. Specifications: application, Mopar small block LA or Magnum V8 engines converted to a carburetor. Type, ready to run. It has a built-in electronic module instead of standard points and condenser. Ignition adjustment equipped with a mechanical centrifugal advance and a vacuum advance regulator. Requirements: it requires an external ignition coil with a resistance of 0.7 to 1.5 ohms. The factory ignition coil from the injection version of the Magnum engine is unfortunately not suitable because it has a resistance of 0.4 to 0.5 ohms. Examples of suitable ignition coils for this distributor include MSD Blaster 2 Ignition Coil 8202, Bosch 02211220022, or Lucas DLB 198. Comparison with the distributor from the fuel-injected version, and here is the new distributor mounted on the engine. The next matter, the intake manifold. I bought this manifold from Speedmaster, formerly known as ProComp Electronics, part number 1147028. Specifications: it features a dual bolt pattern. It fits both classic Mopar LA heads with angled bolts and the newer vertical bolt holes in Magnum 5.2 and 5.9 V8 heads. Dual plane design. Featuring two separate intake runners, it provides high torque in the optimal range of 1500 to 6500 RPM, which is ideal for the street. Carburetor base. Designed for standard 4-barrel carburetors such as Holley or Edelbrock. Thermal insulation. The air gap design, which leaves a space underneath the intake, insulates the fuel from the hot engine oil to improve performance. You also need to purchase a classic thermostat housing from Mopar LA engines, specifically from model year 1975 or older, because the stock one from the fuel-injected Magnum engine will not fit. Carburetor. I chose the Edelbrock 1407. Specifications: performance 750 CFM, large airflow capacity, designed for more powerful or modified V8 engines. Design AFB style, based on the classic proven Carter AFB design. It features a two-piece aluminum body that allows for easy service and tuning without the risk of fuel leaks from the bowl. Type: square bore, a standard base with 4 equal barrels fitting directly onto your Speedmaster manifold. Choke, manual control using a traditional cable from the driver's cabin. Performance characteristics: it features mechanical secondary opening with a counterweighted air valve, known as velocity-sensitive secondaries. This ensures very smooth acceleration without any bogging when you smash the gas pedal. To connect the carburetor to the EFI air filter intake, you just need to make an extension that is 5 centimeters high. What else do you need to do? You need to install a fitting for the water bypass line. I used the fitting from the EFI manifold. Connect the throttle cable. I used the cable from the EFI setup. I custom fabricated a bracket for this cable behind the carburetor, as well as a special linkage for the throttle lever. On the opposite side of the throttle cable, you need to connect the choke cable. Additionally, the alternator and air conditioning compressor bracket required some clearancing to make room for another water fitting, which connects to the heater core hose. The distributor wiring diagram seems pretty straightforward. Finally, you need to modify the alternator so that it has an internal regulator. In the EFI setup, the alternator regulation is handled by the ECU. Therefore, when running a carburetor, this module must be added. I took my EFI alternator to a shop specializing in this type of remanufacturing. The technician there said he added a regulator from a Volvo. Now we will compare both versions of the alternator. The one on the left comes from the EFI version, and the one on the right has been modified for the carbureted engine. The terminal marked as D+ is used to connect to the charging indicator bulb. The other wire from this bulb connects to the switched ignition power. After removing the rear covers, without a regulator, with the Volvo regulator. After removing the brushes and the regulator, EFI brushes, Volvo brushes and regulator. Testing before startup, 12.5 volts. After startup, almost 15 volts. Summary. Converting a Magnum engine from fuel injection to a carburetor setup is very simple. All you need to do is buy a distributor, an intake manifold, a thermostat housing and a thermostat. Clearance the alternator bracket. Add a regulator to the alternator, make a bracket and linkage for the throttle and choke cables, and fabricate the 5 cm extension above the carburetor.